Hi and welcome to my third video on the trapezoidal rule, and in particular approximating areas under curves. And this third video I'm just going to go through the actual generalization of the trapezoidal rule and where it comes from. But I'm not going to build it up generally. I'm going to build it up hopefully through a logical understanding through a more specific example. Not that specific, because I'm saying that this function, which looks suspiciously cubic, it's just a function. I'm not going to tell you what the function is. I'm also going to tell you that we're going to find it with 4 strips. So I'm going to give you that number 4, but it could be n strips, it could be 10, 20, 100. And I'm going to use this width idea here. But I want you to see the build-up of the trapezoidal rule. So let's go back to what we did when we first started looking at trapeziums and actually calculate the area of these 4 trapeziums generally. So I'm going to give these heights as well, which normally you can work out. It's height 0, height 1, height 2, height 3, and height 4. And so then we have 4 areas: area 1, area 2, area 3, and area 4. And hopefully you can see that area 1 is equal to width over 2 times by h0 plus h1. And area 2 is equal to width over 2 times by h1 plus h2. That's the top and that's the bottom. And area 3 is equal to width over 2 h2 plus h3. And area 4 is equal to width over 2 h3 plus h4. So there are 4 areas that we want to find, and we just want to add those together. So it's pretty simple. That means that the area in total will be equal to those 4 areas added together, which is this: width over 2 h0 plus h1 plus width over 2 h1 plus h2 plus width over 2 h2 plus h3 plus width over 2 h3 plus h4. And I've got a common factor of w over 2, so I'll take that at the front. I'm left with h0 plus h1 plus h1 plus h2 plus h3, 2 plus h3 plus h3 plus h4. And close that bracket. And now I can see I've got some common elements here, here, and here. So this is equal to width over 2 h0 plus 2h1 plus 2h2 plus 2h3 plus h4. And that's just equal to width over 2 h0 plus 2 h1 plus h2 plus h3 plus h4. And that looks a lot like the generalization. And in fact, what we've got here are the middle heights, and what we have here are the end heights. And so you can see where this comes from: width over 2 ends plus 2 middles. And if I zoom out here, that leads to this. So we have our generalization, and that's where it comes from. Although I've only shown you for 4 strips, but just imagine if I show you for 10 strips, there's just going to be a lot more things in here. It's going to be all the way up to h10, and there's going to be double of everything in the middle, because it's all counted on 2 trapeziums. So the width is always included in each one. h0 is only attached to 1 trapezium, so it's only counted twice. But h1 is in area 1 and it's in area 2, so that's why you get 2 of them. And h2, area 2 and area 3, so on and so forth. So it gets counted twice as compared to h0 and h4. Something to think about. You pretty much can get away with just using a formula, but you know, maths is so much easier when you understand what you're doing, why you're doing it, and where it's all come from. You'll find that things fall into place, particularly those dreaded complex unfamiliars. All the best.